Hey guys, this is Drew, the SDSU EE tutor, and in this video we're going to take a look at the fundamentals of mesh analysis. The most important thing to remember about mesh analysis is right here. Okay, the voltage rises will equal your voltage drops. So when we're doing mesh analysis, you can look, I've already got the circuit set up. We have two meshes, right, or two loops, and I1 represents mesh current 1 and I2 represents mesh current 2. So the first thing that I want to point out is that the mesh currents are tools. Okay? These are not necessarily the real currents flowing through the wire. Mesh currents are tools that we use to figure out what the real currents are. This is the biggest misconception that majority of people have about this. Okay, they think that this I1, this current right here flowing through this resistor, this 2 ohm resistor, they think that this is the real current. Okay, when you have two meshes that are butted up next to each other, that is not the real current flowing through the wire. The real current flowing through wire is I1 minus I2. Okay, this is the real current. Real current. However, the mesh currents can be the real currents. Okay, so if we look at this mesh 1, I1, up on top, there is no other mesh touching this 1 ohm resistor. Okay, so in this case, the mesh current is the real current. But when you have two meshes butted up next to each other, then you have to subtract one from the other. So keep those things in mind, and let's actually solve the circuit and stop jibber-jabbering. Okay, so let's solve this thing. Taking a look at mesh 1, we will start in this bottom corner and start going up. So we go through this 5-volt battery, and we are going from minus to plus, right? So when you go up through a battery from minus to plus, that is a voltage rise. Okay, so our voltage rise goes on the left side, so 5. And if we look through the rest of the mesh, there is nothing that supplies power. Okay, so everything else will be a voltage drop. So this will equal all of the voltage drops. And our first voltage drop is this 1 ohm resistor, right? And due to the magical equation V equals IR, we can say that the voltage of this resistor will be I1 times 1. Right? Current times resistance gives us voltage. Okay, and then the second resistor. So we have another voltage drop. So that will be plus. Okay, and now this is what I was talking about with the whole, we have to calculate the real current. So as you see, we have I1 coming down right here. Okay, so we will definitely have I1. Right, so I1. But if you look on the opposite side, you've got I2 coming up in the opposite direction. So because I2 is opposing I1, you want to subtract I2 minus I2. Okay, so let's throw some parentheses around this. So this is the real current flowing through this resistor. And the resistance is 2 ohms, so we multiply times 2. Now let's take a look at mesh 2. Alright, so if we look in mesh 2, there are no voltage rises. Okay, we don't see anything that supplies energy. Alright, so this will be 0, no rises, will equal our voltage drops. Okay, so let's start in this corner right over here. Right, you can start anywhere you want in the mesh as long as you make a full circle and get back to that point. So coming down, this will be I2 times our outside 2 ohm resistor, so this will be times 2. Okay, and then we have this resistor in the middle again, plus, it will definitely be I2, right, because we have I2. And then again, so I2 is now coming up this way. However, on the other side we have I1 opposing. Right? So this will be minus I1. Let's throw some parentheses around that. You always start with the mesh current that you were talking about and subtract the opposing current in the opposite branch. Okay, so I will repeat that one more time. You always start with the current that you're talking about in your mesh and then subtract the opposing current from the opposite mesh. However, if we drew the meshes differently, if I1 was going counterclockwise, right, so if the arrow started pointing in the opposite direction, say we started going this way, both of these arrows would be going in the same direction. Right? Our blue and our red would be going in the same direction. If they're going in the same direction, this should be a plus sign. Okay, but we're not dealing with that. Right? Our arrows were opposite, so we're subtracting. Alright, so we have our current times the resistance would be 2 ohms. Right? Notice that this current right here is the actual current flowing through this wire. Okay? Our mesh currents are just tools to figure out the real currents flowing through the wire. So now we have these two equations, and if we simplify, these are the equations we get. So being that this is a college level course, I'm going to assume that you guys know how to do basic algebra, and I1 will give you 2.5 amps, and I2 will give you 1.25 amps. And remember, these guys right here are the mesh currents. Okay, they are tools for figuring out the real currents. Okay, they can be the real currents, but where two meshes butt up against each other, they are not the real currents. They are only tools to figure out the real currents. So if we look back up at our circuit, this branch right here, this does not have any other meshes opposing it. Right? So this branch, the mesh current, is also the real current. So there are 2.5 amps flowing through this branch. The same thing with this branch as well as this branch. Okay, so for mesh 2, this piece of wire, this piece of wire, and this piece of wire do not have any other meshes butted up against it. Right? And what do I mean when I say that? Like another block, right? Another mesh against it. That would be another mesh. There is none of that. So in this case, the mesh current is indeed the real current. So this is 1.25 amps. Now if we look at this center branch right here, right, this does have two meshes right next to each other. So this will be I1 minus I2. Okay, so I1 is 2.5, I2 is 1.25. That means that the current, the actual current, right, not a mesh current, the actual current flowing through this piece of wire and this resistor, this is equal to 2.5 minus 1.25, which will equal 1.25 amps. Okay, that is the real current flowing through this. Alright, so main takeaways from this video. The voltage rises equal the voltage drops when we're going around our loop, and our mesh currents are tools for figuring out the real currents. That's all I got for you guys. Study hard.